In just 4 years, scientists have detected over 1,000 exoplanets just from their shadows. But Kepler has a problem. It can't tell if the shadow is made by a giant gassy planet hostile to life or a potentially habitable Earth-like planet.
What we're measuring when a planet passes in front of its host star is what is the area of the planet relative to the area of the star that it's passing in front of. It's a ratio, basically.
But Jupiter-sized planets crossing giant stars fool Kepler, because they block the same fraction of light as Earth-sized planets crossing smaller stars. To prove a planet is Earth-sized, you first need to measure the size of its star using the world's biggest telescopes. But that's time-consuming, expensive, and it creates a huge exoplanet backlog. But astronomer Kayvan Stassen has come up with an ingenious shortcut by turning the raw Kepler data into sound.
What the Kepler telescope directly measures in the data that we use is the small changes in brightness that a star produces due to the flickering arising from the boiling and roiling motions of gas at its surface. What we can do then is take that light flickering data and transform it in a sound studio, for example, into audio frequencies. And so then we can represent with sound what we're actually detecting with light.
The bigger the star, the more its surface boils with activity, making big stars flicker more powerfully. Converted to sound, this boiling becomes a deafening hiss.
Well, let's listen to some stars.
Okay.
Can we hear the red giant star, please? I'm going to bring up the volume here. This is a very large star, very low density. And so that large amount of hiss is the result of vigorous boiling and churning at the surface of this large red giant star. Can we get the dwarf star, please?
On smaller stars, sunspots dominate the sound profile, creating a low-frequency drone.
It actually sounds like a series of clicks. Krrrr.
But below the clicks lies the faint hiss Kayvan needs to size the star.
Underneath it, at a very low level, is a little bit of hiss. That little bit of sss is actually the light flickering that we're interested in.
By accurately measuring the level of this background hiss, Kayvan can work out the size of the star. In this case, it's around the same size as our star, the Sun. Kayvan's work could be the breakthrough exoplanet hunters have been hoping for. It's cheap, the results are practically instantaneous, and once you know the size of the star, figuring out the size of the planet, casting shadows over it, is child's play.
It feels like a very privileged time to be a scientist, to be an astronomer working in this area and contributing to the hunt for the next Earth. Here we are actually discovering these worlds by the hundreds, and now on the cusp of being able to identify the next Earth.